Hello and welcome to another Pandas FAQ tutorial brought to you by Python for Finance. Today we're going to be looking at how to select data frame rows based on column values using a method called Boolean indexing. And don't worry, this isn't as complex as it might sound. It just means we're creating true or false conditions against which we can evaluate a data frame. In this tutorial, we've got 6 examples. The first of which is very simple and is based on a single condition. We've then got 2 examples where we implement multiple conditions using and/or operators. Examples 4 and 5 are based on datetime splicing. And finally, in example 6, we select data based on items in a list. Don't feel like you have to watch the whole video. Feel free to skip to the relevant section. So the first thing we're going to do is to import our modules. And in this tutorial, we're going to use pandas and datetime. So we import pandas as PD, which is the standard naming convention for pandas in data science. And we're also going to import datetime. Now, you might see other tutorials that reference datetime as DT. This is absolutely fine, but in this case, we are just going to import datetime as itself. And then we can run that cell in Jupyter using Control and Enter. So that's the modules imported. Our next step is to import data from file. Now, in all of our Pandas FAQ tutorials, we are going to use Brent crude data, which we've downloaded from Yahoo Finance. You can find this in our GitHub, and I'll make sure to link that in the description below if you'd like to follow along. Now, we're going to declare our variable dfmaster, and we're going to read in our Excel data using the pandas read Excel method. So we do pd.read_Excel, and then our file name is simply brent_data.xlsx. And then if we run that, that has imported the Excel file, and that's set to dfmaster variable. Now, if we just want to check that we've imported it, we can do df_master.head. And what this is going to do is just print the first 5 rows of our data frame. And as we can see, we've got our index and 6 columns: date, open, high, low, close, and volume. And before we jump into it, we're just going to add one new month column. So we're going to declare df_master. Month is our new column. Let's make sure to put that there. And the way that we're going to get the month is by referencing our date column. So we do df_master, referencing the date column, .dt.month. And then same as before, if we do dfmaster.head, using the head method, gives us the first 5 rows. And as we can see, we've added in column 7, which is month. And we've got July and August values here for some of our data. So you can see 7 and 8. 7 obviously referencing month 7 in our date column, and 8, which is August, referencing August in our date column as well. If we just describe the data, df_master.describe, just before we jump into it, we can see all of our columns here, 3,842 rows of data, with the averages across the board, standard deviations, our minimum, maximum values, and some percentile values in there as well. So we're going to jump into our first example, our first of 6. And our first example is simply selecting rows based on one condition. Now, in each of our examples, what we're going to do is create a temporary data frame. And we do this just to avoid making any changes to our master so that we can keep the consistency running throughout the tutorial. So we need to make sure that this is run. So we run this cell, and then we're going to put our code in here. So we've just got a prompt, which is to select rows where the high price values are greater than the average high price. And the way that we do this is that we declare df is equal to df.loc, and then we reference our high column. So we do df high, and based on our prompt, we want rows where the high price is greater than the average high price. So we use the greater than operator here. And again, df high dot mean. So what this is going to do is it's going to set our df variable here equal to a data frame where the high values are greater than the average. And if we just do df.describe, which is going to explain our new temporary data frame, you can see what has happened here. So in our original df master, we have over 3,000 values, and you can see that now in our new data frame, we've got 1,700. The mean before, $79, moving to $104. So you can see the data frame has been changed and we've applied the filter correctly. Now we're going to apply multiple conditions, and this requires using some rather different operators. And our prompt here is to select rows where the open price is less than $50 and where daily traded volume is greater than average. And again, what we're going to do here is comment in this bit of code. So we have df equal to copy of our master data frame. Now, what we're going to do is we need to apply these multiple conditions. So we're going to set our temporary data frame df is equal to df.loc. This is pretty key. And then we need to start building up our conditions, our Boolean conditions. So it helps to put parentheses, and then we're using our AND operator. So you can see we start to build up the conditions within our parentheses. And our first condition, select rows where the open price is less than $50. So we're doing df open, and that needs to be less than $50. Our second condition, past the ampersand, is we do daily traded volume is greater than average. So we reference dm, and we're referencing volume, is greater than the average. So df volume dot mean, and that's going to give us the average. So if we again use df.describe to explain our code, we can see we now have a data frame length of 472. And what's happened to our averages? So our open is below 50, and that's explained by our maximum value down here, 49.99002. And df volume is greater than the average. So our new average for volume, 30759 versus 7849 and 16,611 in our original master data set. And you can play around with these conditions, again, as I mentioned in the first example. So if we wanted to get prices that are greater than 50, we can change the operators to represent that. Now, example 3 is very much a follow-on from the second example, except rather than using the AND operator, we're going to use the OR operator. And in Python, that's represented by a vertical line. So what we're going to do is create our temporary data frame again, and then start implementing our code. So for the sake of brevity, we're going to copy in our code from example 2, and then we're going to run this again, except we need to change our conditions. And you can see when we run this code, we get different values to example 2. Now, example 4 is slightly different in so much that we're going to be selecting rows based on date time values. And what we want to do here is select price data, which was issued after the 1st of January 2015. So we need to comment in this code. df is equal to our copy. And then what we want to do is start building this up. So it's a little bit different, and the first thing we have to do is declare our date in datetime format. And we do this if we say my date is equal to datetime dot datetime, and this is where we declare the time. So year is equal to 2015, our month is equal to January, which is 1, and our day is equal to the 1st, which is therefore also 1. So this variable then is going to be datetime, the 1st of January 2015, and then as we've done before in example 1, we build up our condition. So we're setting df is equal to df.loc, and we want square brackets. And then we set df date is greater than or equal to my date. And you can see that code has now run. And if we want to just show our data frame, we can see index value of 1818. So it shows you that we filtered out all of the values before this date, and the first date being the 2nd of January 2015. Now, just to show you that this is working, we'll just change 15 to 16, create a new copy of our master data frame, and then run this again. And you'll see that what this does is it changes it to 2016, and our first value is the 4th of January 2016. Now, just one thing to be aware of is that this is only going to work where our date column is set as a date time. So if we just show df.dtypes, and sorry, it's not a method. If we run dtyped, you can see that our date column is of type datetime 64 ns. If this was set to object or if this was set to string, this condition isn't going to work. So before you set this condition, just make sure that date is datetime 64. Now, for example 5, what we're going to do is select values based on the month of the year. And our prompt here is to select March price data. So we set our temporary data frame. And then what we want to do is to select March price data. So you might remember from earlier, we set a new column, the month column. And March is month 3. So we're going to start by declaring our temporary data frame is equal to df.loc. And then we have df month, and that is equal to month 3, which is March. And then if we do df dot head, which is going to give us our first 5 rows, and you can see all of our data is simply March data as well. Now, in our last example, we want to select rows whose column value is in a list. Now, this is slightly trickier, but not too much trickier. Again, declare our temporary data frame, and then we're going to declare our list. And our prompt is to select data from a list of summer months. So our summer months, we're going to call April, May, June, July, August, September. And I know that we can do this with a generator, but for the sake of ease, I'm just going to write this out in a list. And then we're going to set our new data frame equal to df.loc. And then we're referencing our month column again. So we do df month, if I can spell. And then this is a little bit different. So we're going to use the .isin method. And then we're going to reference months, like so. Now, if I can print that df month, I need to reference summer month. Reference summer months, what you'll see is that we have month 7, 8, 9, but we also have 4, 5, 6, 7, 8, 9 in there as well. And if we want to negate the Boolean, so essentially have the opposite of this condition, so we'd be getting months 1, 2, 3, and 10, 11, and 12, so January, February, March, October, November, December, then what we can do is we can put a tilde in there as well. So we can put in our tilde before we start referencing the data frame. So if we just create our copy again, and then create our copy and run this code, what you'll see is that we have clearly January months here, and we have our October months as well, just by using our tilde here. That's it for this Pandas FAQ lesson. If you have any remarks, observations, or any burning Python or Pandas questions, be sure to leave them in the comments and we'll pick out the most upvoted or most interesting for future videos. Thanks for watching.